We started the fourth quarter by looking at solutions. Solutions are covered in chapters 17 and 18 of your textbook. One important concept about solutions is their concentration. And there are lots of ways to measure the concentration of a solution, like density, solubility, molarity, and so on. For example, in number 79, it gives us the solubility of salt per 100 grams of water at a certain temperature. So in this case, it says there's 36.2 grams of salt that can dissolve per 100 grams of water. And if only 50 grams of water are used to dissolve the salt, then you can set up a proportion. 36.2 grams of salt over 100 grams of water is equal to X grams of salt that can dissolve per 50 grams of water. And that would allow you to solve for X, which tells you how much salt could dissolve. Or another way to think about it is, if you have only half the amount of water, 50 grams instead of 100 grams, you should only be able to dissolve half the amount of salt. So half of 36.2 would be 18.1, which is what we get for our answer. Probably the most common way to measure a solution's concentration is molarity. Its equation is molarity, capital M, is equal to the moles of the solute divided by liters of solution. So for number 81, we need to solve for the mass, or number of grams, of lithium oxide to make the solution. Now we know what concentration we want. It says that the solution is going to be 5 molar, and we know how much of the solution we're going to make, which is 500 milliliters. The important thing to remember is if the equation is moles per liter, we've got to divide this by 1,000 to convert the milliliters to liters. So here we have 0.5 molar is equal to X moles over 0.5 liters. So solving for X, we get the moles of lithium oxide, which then we can convert to grams by multiplying by the molar mass of Li2O. Molar mass is 29.8, so multiplying these two values gives us the total mass of lithium oxide that we need to dissolve in the water. The most recent property of solutions that we've been studying is whether the solutions were acidic, basic, or neutral. And we can recognize an acid by hydrogen ions in its formula, or a base by hydroxide ions in its formula. Acids have more hydrogen ions than hydroxide ions, bases have more hydroxide ions than hydrogen ions, and neutral solutions have an equal amount of hydrogen and hydroxide ions. And if we want to quantify that and do a calculation of the pH of the solution, anytime that they give us a hydrogen ion concentration, we can take the negative log of that hydrogen concentration, and that gets us the pH. Or you could solve for the pOH by taking the negative log of the hydroxide concentration to get the pOH. The pH and pOH values have to add up to 14, and the pH scale ranges from 0 to 14. The pH in the middle, pH of 7, is a neutral solution. pH is less than 7 are acidic, and pH is greater than 7 are bases.